So, hello everyone. It's been a while. I haven't recorded any video, and I won't say much. I don't really have any specific explanation of why of the video delays, but let's not get into that. Let's go straight to the point instead. So, today I bring you guys my major project, which has been a headache, but it is what it is. That's engineering, right? So I've been tasked to build a robot that is basically going to, so the name of the major project is not directly in line with what I'm doing. So I've been tasked to make a humanoid sort of robot, not specifically humanoid, a robot that identifies isolated kids in a nursery school or something like that, and the robot tries to interact with them. So in this there are two challenges. I'm a mechanical engineer, so there are two major challenges: making the humanoid mechanically wise and motion, all of that, and then the self-localization and everything of the robot. And then it comes to the human interaction part, human detection, etc. And yeah, I'm just doing it as much as I can. Not, I'm sure I have to present it in less than a month now, but I've been doing my research. I've challenged myself with quite a few things. So this is what I've ended up doing. Let me get a paper or my tablet, I guess. Let me put this aside. I'll just show you guys what I've been doing. Let me open this. I do have the CAD of it. It's just that I don't have it on shape. So basically, what I've done, I have set some goals. So basically, I wanted the self-mapping, localization, maybe human detection, and etc. So, and also the motion part, I had to decide. I had to basically decide everything. So what I end up doing is build a robot. I don't have a pen right now, so it's okay, guys. Build a robot like this. Basically, I've placed a motor over here. I placed another motor over here. Actually, it's not like that. Here I have a accelerometer and gyro, and here I have placed a motor, another motor over here. We make it red, motor, and then I've placed my batteries over here. It's a forest battery. I'll show you all of this. I already have it. Then I made a custom PCB which controls the motors and take the IMU data and etc. And above here we have a plate, splits these two, and here we have Raspberry Pi with some modules on top of it, and then here we have the end plate which will have a LiDAR sensor here, which I recently got. In middle, in front, I have kept a camera. So there is a mount for a camera that is here, and I have a millimeter wave sensor over here. And wheels. So now, since this is a two-wheel robot, the first task is to get it balanced, standing upright. I managed to get it standing upright, but as soon as you bump into it or touch it, it runs out of balance and falls, which I'm trying to solve till date. In the meanwhile, I've been purchasing the other parts to do SLAM algorithm so that it can map and locate himself, and also I'm going to do some human detection or maybe environment detection like identifying like this is a corridor or something, or this is a object, things like that, and a millimeter wave sensor that can exactly tell that this is a human being. And yeah, so this is what I've been trying to do. First doing two-wheel balance, and then doing slam in a two-wheel balance robot, then implementing this environment perception and all. Okay, so let's move into the parts. um, so the parts, I have purchased parts. Let me have a drink. I have purchased the parts to build the robot. I already had a Raspberry Pi 4, unfortunately a 1 GB one, but it's okay. And I've also made some PCBs, in fact. Let me get those. Final year project. As you know, I got my PCBs from JLC PCB. So I've made two PCBs. This is the one that controls the motors, as you can see. And this is the one that is going above. It's like a hat, it goes above the Raspberry Pi. I'll get into that in a bit. And here, since I ordered two PCBs semi-assembled, so one of them that is here, it's actually semi-assembled. You can see there are some components. So moving past this, let me close this. Let's get to the parts then. So I have here this part semi-assembled. I'll just put everything on the table. I have here the battery pack. I have here the camera and the sensor, which I got them today. And I'll keep this one like this. Have here the motors. These are the second motors. I just got them yesterday. So the previous motors were this one, and as you can see, it's more RPM. I went now reduce the RPM because I need more torque, things that I figured out along the time. So because of the change in motor, the gearbox was slightly longer. I had to print new plates, but these were the previous plates. You can see just flat, and these ones had some protrusion like that. And you ask why you had to do this modification. Because as you can see, it's the bottom part of my robot. This is all 3D printed, and we have a IMU over here, which is a MPU 6500. So if I keep this motor over here, this is totally fine. It was totally fine like that. There's clearance over there. But then if I keep this one over here inside there, it was not fitting with those plates. So now I have kept the motors a little bit more in, as you can see here, and they are now well accommodated. And I've also printed different plate because it was quite hard to turn on the robot, because you'll understand it in a bit. It was I made with this cutout, and also some vents here for cooling of the motors. Basically same thing, is just a little bit optimized. Like in here, a heat insert, because I ran out of them. They're over. And yeah, here we have bolts, because I disassembled this robot. It was fully assembled. I disassembled it to accommodate the new parts. With the bolts that came out of it, some new bolts that are going in, additional bolts because more parts are coming into picture. I've kept my phone in this orientation, but it's not actually helping. So let me try to zoom out a little bit. Yeah. So after that, I'll should bring to the picture. So yeah, we have our IMU over here. I'll just keep this in here. And we have here our LiDAR sensor. Very expensive guy. I'm regretting till now purchasing it. This is the new plate to accommodate the LiDAR. I'll just open the LiDAR here. keep this outside with all these guys. Nice packaging though, I appreciate the packaging. Yeah, that's basically everything that I have. So basically I've already placed these spacers over here. I'll keep the lighter just slightly elevated from this plate. So basically this guy comes over here, and then we screw them like that. Hopefully it aligns, I mean. And yeah, it does align. So this guy, we can keep this inside the box lighter. And let's get into this guy. This is quite interesting. So here we have our PCB fully assembled. It's a STM based development board. I won't call them development board, it's just PCB F4 based. It's a F446, sorry. And yeah, it's fully assembled. It's quite a beautiful PCB. In fact, this is a PCB with 0 flaws. It has 0 flaws that I even want to measure the voltage ripple. So basically what is happening in this PCB, I have here the voltage input, which is a 4S battery, as you can see here. It's fed to a bank of capacitors, going to a buck regulator, which is reducing it to 5 volts. That powers our Raspberry above here. So Raspberry gets 5 volts through this cable. And after that, here also we have CAN on this part, which is being fed to the Raspberry. So this is a split architecture. We are basically ensuring this PCB makes sure that the robot stays balanced, and the Raspberry Pi will take care of the computational part, the camera, and blah blah blah. So the Raspberry Pi just commands the PCB like go forward, go back, turn left, or turn right through CAN. And the CAN also feeds feedback like what is the battery status and all these other things. And we have here USB if you want to debug, and also a UART port if you want to connect, for example, a Bluetooth module, just to if you want to debug anything that, because this is a dump UART, to just dump everything that is happening in the robot. I will have a time lapse of assembling this later. I won't assemble it here because of course there will be hiccups. So basically the motors come over here. I'll get the other motors. So the motors, these ones come over here. These motors have encoders. So let's talk about these interesting motors. These are N25 12 volt motors, which I'm powering with 16 volts, ironically, but yeah. And because of the PWM, we are able to adjust it through the motor driver, which is a DRV. I forgot the name. I'll tell you guys later. I'll just write it down on the video. So this is a motor with encoder. So it's a 2-phase encoder being fed to this motor, as you can see here, AB, minus, plus, etc. And yeah, so this pin out, it's directly coming here. You just plug this guy here, and you plug the IMU, this guy over here, over SPI. And we have here a EEPROM on this board. We have a EEPROM that is, what is that guy's name? I even forgot. I have here in one of my bill of materials, I have a 8024C02 EEPROM that I'm keeping all the PID set values, the fuzzy set values. I'm using PID now, but I'm going to use a hybrid fuzzy tuned PID. Still looking into that, so many problems. Anyways, so yeah, this is basically it. And this is the board that I was saying. This is just a breaker board for LiDAR sensors, which will have CTs mounts. So some linear lidars will be here, like a TOF type of lidar, time of flight lidars will be here. To here, just to detect objects in front so that the robot won't run into them. And here we connect our 360 lidar, and this some basic LEDs just to show the status of the robot. And here we have CAN and RS485. From this hat here, I have a CAN and RS485 hat connected, and this board also powers the fan of the Raspberry Pi. and some fans that cool the robot down. And this is a XT30 connector. It's a quite a compact system. Camera that I'm using, this one, it's Raspberry Pi camera model 2, which is this one. It's brand new. This is a sensor, 24 gigahertz, and I fumbled here, so I only used 2 of these, but yeah, this is the camera and the sensor. I'm going to eventually build a cover that covers at least the camera and just keeps this slightly open like that. And battery, it's a 4S battery. The capacity of it is like these are is 4.5 it's 18650. It's I think is 4.5 ampere hours or 3.5, I don't remember correctly. I kind of forgot everything about this. I built them long time ago. I soldered them. I don't have a spot welder, and I didn't want to buy just for this. And here we have the BMS. It's a dumb BMS for over voltage, over current, all these things. And XT30 again. So yeah, that's basically the overview of the robot. It was just a quick walk around. I'm going to put a time lapse of assembling this, and actually we put the time lapse of assembling the previous one. This is basically the same thing, just this was not there. And we'll catch up on next video. Thank you.